Okay, can you see my title deck?
Yeah, I can see the slide.
Yep.
There we go. It works. I can do this.
Icons do IT.
Exactly. It's not like it's my job or anything. Okay, so good morning, everybody. My name, if you don't know me, is Sam McGeown, and I've been part of the London VMUG now. I think 2012 or 2013 was the first, probably 2012 was the first time that I came to London VMUG. So next year will be 10 years. That's insane. So yeah, long time member of the London VMUG. And for my day job, I'm working for VMware as part of the cloud management business unit. I work in technical marketing for vRealize automation. And specific part of my job is working with CodeStream, which is our sort of CI/CD tool, and Kubernetes and modern apps and cloud native and all that sort of things, and how that integrates with the vRealize automation. So what I'm going to present on today is not based around products. Is that a cheer I hear? I'm not selling you a product here. I'm not even really doing it as a let's have a look at VRA kind of thing. I'm really want to take you through a process that I've kind of been working through to see how we take the benefits of DevOps and all of those kind of principles and theories and everything that happens around DevOps, and how we apply that to your everyday virtualization admin task, how that influences how we manage our environments and that sort of thing. So hopefully this is going to be useful. It isn't directly technology. It's a lot of it is around theory and around potentially how you might approach something, rather than being, use this product to do this or use that product to do that. Obviously, I would tell you that, use VRA to do all of these things because it's awesome, but that's only because I'm paid to do that. So that's my introduction. The first section of this is going to be having a look at how we define DevOps, because, you could Google DevOps and there are a ton of slightly different DevOps definitions out there. And so what I'm going to do is really show my take on it. You can feel free to disagree. I'm quite happy to discuss that. I'm quite happy to be corrected. It's really, yeah, think of this more as a rambling wander through my thinking on this subject, rather than than an opus of education proportions. So Wikipedia, good old Wikipedia, defines DevOps as a set of practices that combine software development and IT technology operations, which aims to shorten the system's development lifecycle and provide continuous delivery and high software quality. Thank you, Wikipedia. So, I mean, at its heart, DevOps methodologies are designed to bridge that gap between developers and operations teams. And the reason for this is that we all know developers and operations teams have different objectives. A developer, their primary goal is they want to write code and create new features for the customers. And an operator, they're after maintaining that site reliability kind of side of things. They want to have the most amount of uptime they can. They want their performant environment. And so this can lead to conflicting approaches, because what making changes to an environment inherently brings new. Can you hear my daughter screaming in the background? Sorry about that. Inherently, making changes to an environment risks the stability of a running system. So if you make a change, the chances are that it's more likely to cause a problem than if you do not make a change. The problem is, and this is where the conflict is in order to introduce new features and to drive a product forward, you have to keep innovating. So there is these sort of two sides of a coin that happen with the DevOps. And when the DevOps methodology is really trying to bring into balance that ability to introduce new features while maintaining the stability of a system. And so you get this thing where, stability is operations team's primary concern, but development team have just handed over a bunch of new code, and who's responsible for checking that code quality? Is it developers? Is it the operations team? Who's responsible if it introduces a performance issue? Is that a developer's job, or is that an operations team's job? We all know that resolving incidents is likely to be an operations job, but should it be just the operations job? Well, that's the heart of DevOps, to bring these two sides of the coin together. And the finer points of DevOps, that can be quite subjective, but most people would agree that DevOps should have the benefits of reducing the time it takes to deliver value. So bringing your product to market, or being able to introduce a new feature in the shortest amount of time possible. While you're doing that, you need to reduce the risk. And so you create these faster releases of smaller, more frequent updates, and you iterate your releases in a small, controlled manner. And by that you reduce the risk to introducing change. It also should bring earlier detection and faster resolution of incidents. So with automation and testing and traceability, you should be able to find what change made the break and fix it much quicker than a big bang releasing jump from version 1 to version 2 of a product. You might introduce failures that you've then got to check the whole code base for. And finally, increasing customer satisfaction, which is sounds like a marketing term, but like customers are going to be happy when you can launch new features, okay, and when there's something new that they're getting, but they're also going to be happy when it's stable. And in order to get both of those things, to have a happy customer, you want to have new features and you want stability. And so you also want to be able to incorporate things like customer feedback into the development process, so that customers can have a direct influence over things like new features. And this again is a way of increasing customer satisfaction. So this is my sort of nutshell of the DevOps methodology, DevOps approach, is to provide these a resolution for these two conflicting sides of the same coin, and to provide these benefits, that at the end of the day, we're all in we all have customers, whether they're paying customers or internal customers or whatever. We want to have satisfied customers. It makes our life easier. It makes everything work better. So how does DevOps go about doing this in a practical way? Well, hopefully everyone has seen in the past the DevOps cycle. It's quite prevalent, throughout the IT world now, to have seen this infinite loop. And the idea of the DevOps cycle is that we go around this loop as fast as we possibly can, and as many times as we can, in talking about releasing to production, multiple times a day, hundreds of times a day, whatever. But if we take a little walk around this DevOps cycle, and we start in the planning phase, and really this is where you're organizing your tasks and schedules, and you're setting up project management tools. The idea is that you create a user story, to use the software, the agile methodology, and you write tickets in the form of a user story, which allow developers and operations to understand what development needs to be done, so what changes need to be made and why. And so you have this what, why, and acceptance criteria idea, where you can say, what are we going to change, why are we going to change it, and what's the acceptance of this change. So that's the first step in any of these, in the DevOps cycle, is the planning stage. And it is an important one, because as you can see, the the tail end of the loop feeds back into this planning stage. And so we'll talk about it when we get there, but it's important that this planning stage is informed by the need. So the second stage is actual coding, and bear with me here if you're not into programming or not into developing code yet. You will be at some point if you carry on working in IT. But I'm trying to sort of level set around the DevOps cycle here, and then we'll explain how this can relate to your vSphere admin environment. So coding, this is where you begin to write code, develop code, and also you have some kind of peer review. Typically, you write a new section of code, you should be writing tests for it, and you merge it into a version control system. So you're merging it into your GitHub, GitLab, whatever. And this is really important, the ability for both developers and operators alike to be able to access the code, to be able to access what's going on, because this is your system of record, it's your audit trail, it's your primary tool really for managing change. So once we've hit that code, the code's been created, ideally we are automating this next step. And the code is built from source code into the desired format. So whether that's compiling a binary, building a new artifact, some kind of object or artifact is released from the code that you've written. And this is where terms like continuous integration and continuous delivery come along, and we start automating the process of releasing through the life cycle. Testing, now this is an interesting one because testing is a crucial stage in reducing risk, and automated testing preloads a whole bunch of tests into your pipeline or into your development. So by doing automating tests, you can reduce the risk that any bugs or any regression is implemented into production. And you have to implement testing tools in your workflow to ensure that you get the best quality of outcome. So this phase is where we're likely to introduce another concept, which is the infrastructure as code concept, which we'll be talking about in a little bit. But you might be spinning up an entire staging environment as an infrastructure as code unit, and to ensure that your staging and testing environments are actually the same as your production environments. And there's various types of tests that we might be doing on this, such as unit testing, which is where we test individual units of code, like a function or an individual component of a system, and we might test that this has the properties and expected outcomes that we're looking at. Then you might have smoke testing, which will test the basic functionality of what you're building. Integration testing would be testing how that integrates with other components. So if you're deploying an application as part of a virtual machine, you might be testing that, does this actually integrate with my Active Directory authentication correctly? It's about how what you're deploying is integrating with external systems and external modules. Acceptance testing, so this would be does it meet the plan, does it meet what we've requested in our planning phase, and whether our the outcome of what we've asked for is actually correct. And we also need things like security and vulnerability testing, and all of these can be automated. You may find that automated security testing is a bit of a tricky subject with security teams. And acceptance testing generally will, because it's a user story, will require a user to test it. So those final two phases aren't normally as automated, but can be automated in some fashions. Next on, we move into the release phase, and this at this point, we should have a really high level of confidence in what it is that we're building. It should have gone through enough testing that we are reasonably comfortable to deploy this into production. And so the release phase basically, might tag a new version that we are happy is ready to be deployed. And depending on how confident you are in the process and the level of maturity within the sort of DevOps practice, you might have a pipeline here which releases builds to production automatically, or you might be using things like feature flags or scheduled releases, or even a manual release approval here. But it is a drawing a line in the sand, or drawing a circle around an object and saying this is ready to go. Next is the deploy phase, and this is where our operations take over, typically to release a new feature or a new version into production. Ideally, as automation is one of the DevOps principles, we should be trying to set up what's called continuous deployment here, which is going to automatically deploy into production when we release a new version. But again, if we're using infrastructure as code, we should have a high level of confidence that what we're releasing into production is going to work in exactly the same way as what we released into the testing, or what we used for the testing environment. Then once it's released, we move into what's called the operate phase, and the operate phase, or configuring infrastructure phase, means that the operations environment, the operations team have now built or maintained an infrastructure, and we are able to then run our new code or our new artifact in production. We would be providing a way of capturing information from the operations team. So things like capturing user feedback, being able to address security issues, auto scaling, things like that. These all fall under the operating of the artifact. And then related but not entirely the same is the monitoring step. And the monitoring step, as I mentioned before, is really important, because what we want to take is the information that's gathered from the monitoring phase and the operating phase, and we want to feed that back into the planning for the next loop around the cycle. So this is what allows us to fix incidents faster and to create a better end user experience, is this capturing of performance metrics and logging data and error data and user feedback, and actually use that to iterate and move around the loop again. And we should also examine the actual pipeline itself. So our actual process itself should be examined for any inefficiencies that are happening within that. If there's a manual process which takes 3 days, then obviously we're not going to be releasing anything on a day-to-day basis. So you need to look at optimizing to get around this cycle as many times as possible. So there are a couple of things that I touched on as we went around the loop that I wanted to just expand on slightly. The first one of these, some of these continuous phrases: continuous development, continuous integration, continuous testing. And this is the idea that, with automation and automating processes, we can try and get this continuous loop round the cycle as quickly as possible. So continuous development is when we're making loads of small incremental changes, we're iterating over changes, and those updates are made on an almost continuous basis. And this leads into the many releases a day, fastest round this DevOps cycle loop idea. The continuous integration, which is covering this sort of code and build phases. This is when we take those very small iterative updates to the code or iterative updates to the configuration, and we merge them and build them straight away. So they're merged into a code base and built straight away, rather than bundling everything up into one big lump and then building. The incremental changes reduce the amount of risk and allow us to, again, move faster around this DevOps cycle. Continuous testing, well, I think that's probably one of the simplest ones to explain. This is automated testing of the build. So this is where our unit testing or automated testing of released objects happens as part of the build process, and then moving into the test process. And the more that can be automated, the more sort of continuous idea that we get. Similarly, continuous deployment. This is so there's continuous deployment and there's continuous delivery, and they're two very similar concepts, but typically continuous delivery is just one step further than continuous deployment. So continuous deployment means that we have such a high confidence in the code quality or the object quality that when it's released, that we're able to automatically deploy this new version. So continuous deployment is around like having such confidence in your testing that you're able to release it and automatically deploy this into a production environment. And this is where like everyone in the ops team sort of clenches and goes, "Are you sure?" Because it's something that comes like, it's not as natural to an operations team to say, yeah, we want to just release every single change straight away. And then finally, it's continuous monitoring. So continuous monitoring is that process that I was talking about, where through the operations feedback, through the monitoring feedback, collection of errors, collection of issues and statistics, and monitoring information, we feed back into that planning phase. And crucially, that feedback is acted upon in the next cycle around. So but this can also, feed into auto scaling and auto remediation, where, we're monitoring a web server, that web server is constrained on resource, and we automatically scale that up as part of a process that is automated, or auto remediation on a desired state. So if if you have an application which you've deployed and it's supposed to have 3 copies running, and your monitoring detects that only 2 copies are running, well, what's the remediation for that? It's to deploy a new version, much like you see in Kubernetes environments. So that's continuous monitoring. So all of this, I've chucked out a whole bunch of terms. I've chucked out a whole load of kind of process. And the question that we really want to ask is, how does this affect me? This is great for software development. How does this relate to a virtualization admin, a cloud admin, a VMware admin? How does that relate to, obviously you're not going to be deploying a virtual machine, the same virtual machine 50 times a day. How does this work? How does this translate? And to me, the two main sort of thrusts of this are infrastructure as code and GitOps. Now, infrastructure as code, obviously, that relates to infrastructure, and we're familiar with infrastructure and we're comfortable with infrastructure. And infrastructure as code is a way of capturing all of the configuration and all of what we typically would create into an infrastructure, but to capture it in a form of code. And this helps us in several aspects. When we're trying to operate cloud-like infrastructure in a dynamic nature, the ability to spin up a whole bunch of virtual machines or a whole bunch of servers in a very short amount of time can lead to things like server sprawl, where we've got servers that we just don't really know what they're doing. But no, everyone's too afraid to turn them off because we're not sure what they're for. Configuration drift and snowflakes, where you've got a running environment and nobody wants to touch it because nobody's quite sure which of the changes that have been made to it are the critical ones that affect performance. And we can't migrate to a new system because we're not entirely sure of capturing all of the configuration that's in the old system. And it's about ensuring how servers that are deployed in different environments are going to be functionally the same when a new version of, say, an application is released. how do we know that the server that we're running in our test environment is going to perform the same and perform as with the same amount of same configuration as we have when we release it to production? And the manual synchronization between two different environments, someone might go in and make an environment variable change in a test environment, which makes the test work. And then we go and release the software in production, and that same change hasn't been made in production. So we have these challenges of configuration that Snowflake's sort of Snowflake servers, each with their own unique peculiarities in each environment. So this gives us the problem of environments becoming inconsistent, unreliable, and fragile. So that's what infrastructure as code really seeks to address and seeks to challenge. And an extension of that is GitOps, and GitOps extends the infrastructure as code because it allows us to use Git as a single source of truth for the desired state of our environments, but it also acts as a source of truth for our operations as well. So GitOps extends the idea that we can have our infrastructure as code and makes Git the single focus of how we make operations changes within our environment. Because environments are described as in declarative code, we make a change by issuing a pull request to Git, whether that's creating an environment, updating, or destroying an environment. It's all done by sort of issuing commands into Git. And we should also we can also extend the monitoring phase of DevOps, or include the monitoring phase where we should be able to observe a deployed environment, and we should be able to detect whether the desired state is, it's in the desired state, whether it's been observed as the same, which is, converged, or whether we're diverged from the desired state, and so it's different from the state that we're after. Have I lost everyone? Have you all gone to sleep? I'm hoping you've not, but
I'm still awake.
Oh, good. So, moving on. This is a slide that I from a webinar I did last year, but I still really like the idea of this idea of the mechanics of infrastructure as code. In this diagram, in that we start off with some components in the left hand side. So we have variables, which are things that we can change on like a per deployment basis, like the name of a VM, or the username that's going to be created within it, and these are things that can be provided at the time we execute our infrastructure as code. So it can be from a file that is a file of variables. It could be inputs from a pipeline, or inputs into an environment variable, or an answer file, or an API call, but there's some kind of method for capturing inputs and variables. And the second part is the definition, and this is the code description of a desired end state. And we use the variables to customize each deployment of the end state. And typically we have we have declarative state here rather than imperative, and I'm going to go through that in a minute. But this describes our desired end state, but it doesn't tell us how we're going to get to there. It's literally a snapshot of what we want. And so these two portions come together, and the state that we want and the variables that will go into that state come together to provide us with our infrastructure as code definition. And so typically, you might have what's called a domain specific language, such as, if you're using Terraform, you have HashiCorp configuration language, or you might have a more generic data structure in JSON or YAML. For example, if you're using AWS CloudFormation, you would be using a more generic language. But what this allows us to do is really manage configuration or desired state, it allows us to manage it as code, and this brings with it the ability to store it within source control. And source control in this diagram is a little green box in the bottom left hand corner, but it's really once you get this source control and extension through GitOps, it becomes a really powerful thing, and source control becomes more of the central object. But the reason we want to use source control is that control aspect of it. We have tightly controlled versioning where we have the ability to roll back to previous versions with confidence that this was a previous version that was released and worked. We can also use the source control when we're combining a definition with variables. We can use source control to stamp out multiple environments with different configurations or different variables. So, production, test, development environments can all have the same source definition with slightly different variables defining the endpoint. And also, committing stuff into source control, if we're doing it right, we're using commit messages, and we have this documentation, automatic documentation of what's changed, who's changed it, and ideally why they've made a change. So you combine that with the idea of making really small incremental changes, and each incremental change is documented by your commit message. You get this sort of history of the environment being built, and you can roll back to specific stages, or you can create branches out and test stages without a certain commit in them and things like that. And it's all these sort of software development ideas can then become applied to your infrastructure. And so the next, once we've got our code definition, now what I've termed in this slide is a fulfillment engine, some kind of understanding, logic, and integration with infrastructure as service or containers as service, and probably to some extent platform as service, not so much maybe function as service and software as service, but potentially. But the idea of this fulfillment engine is responsible for taking a code definition and implementing it into a state. It knows how to communicate with various infrastructure endpoints, and if you were, say, defining a virtual machine, it would hopefully know how to present that virtual machine and create a virtual machine in EC2 or in vSphere or in GCP or in Azure. It should be providing a translation between what we're asking for and what we're getting in the end. And what this lets us do, once we've got our state defined and specified in infrastructure as code, it allows us to move into this. This is a lovely slide, which was not hastily put together yesterday, because all of the slides that I had weren't quite saying what I wanted to say. But here we've got Git right in the center, and we've got a little halo around it because Git is our single source of truth, and this is our kind of GitOps process happening here, where we're identifying, if we go from the far left, we're identifying a need and writing some code, so making a change to our infrastructure as code definition. Excuse me. We're making a change to code. We're either creating a new object, we're deleting an object, but at some point we're making a change to code, and we commit that code through a pull request into our source control, our Git environment. Ideally, somewhat before that triggers a pipeline, someone's going to review that, and this is one of the sort of things from from the software development world, where peer reviews actually provide a sort of a first safety net. Have you made a typo that's going to cause an outage or break something? But once we've got this code committed and it's been reviewed, then we can automatically trigger a pipeline to release this code, and we start. This process reflects the moving around the DevOps cycle, where we're triggering a pipeline to some form of orchestrator, and that orchestrator takes, or as it was previously termed, the fulfillment engine in my infrastructure as code slide. This takes what we've written and takes what we've defined and deploys it to our infrastructure and gives us that product of an infrastructure state. And this is really the state that is defined should be a reflection of our desired state. So the infrastructure as code provides us with a desired state. The orchestrator creates that desired state for us, and our infrastructure state should then be able to be verified against the code that we've got. So we should be able to take a look at what the state of our environment is, and look at the code definition and say, yeah, that's correct. That's not diverged from what we're after. So our state is converged with our desired state. And we can do this through monitoring. And our monitoring can do things for various things. So our monitoring can raise alerts for something that's out of band. So our RAM usage is too high, and it can create an alert which identifies the need. It can raise an alert to say that we're diverged from our single source of truth, which is our Git environment. But it can also provide a way of automating that. I talked about auto scaling and auto remediation before. If our monitoring can actually identify the issue and identify what needs to change, we need to increase the amount of RAM allocated, then it can actually skip that manual step of us as an operator identifying a need, and actually automate through that identifying a need process and generate code which then is automatically committed into the system. But this should now seem like a familiar cycle. That DevOps cycle happening in an infrastructure kind of world should be a reflection of the processes that we're going through and how we're managing this. But you can see, with GitOps, Git really becomes our single source of truth. And as I mentioned before, we want to make a change to an environment. We write code and we commit it to Git, and it goes out and orchestrates the changes. If we want to operate an environment, we set our desired state and we make the change through our single source of truth, which has all of those benefits that is the reason why software developers use concurrent versioning. So this is all, it's all quite theoretical. It's all quite, what's the word? Abstract in many senses. So I'm going to move on and try and ground this in a bit more of a, bit more of a method that makes sense to me. So this is one of my favorite XKCD comics, which it's an old one, but it's still one of my favorites. I try it on my wife all the time and it never works, but I'm hoping one day, given enough education, it will produce a sandwich for me. But based on this idea, I want to explore a few more of the themes around how we automate and why we automate things in this process. So, declarative versus imperative automation. Now, historically, we as in operations, as administrators, as cloud admins, whatever, we tend to work with the imperative scripting approach, or a pipeline approach that doesn't necessarily provide the same outcome that we want in a GitOps environment. So when we talk about a declarative approach, if I want a sandwich, which I'm quite hungry now, I do want a sandwich, but I don't want to make the sandwich myself. I want to describe the sandwich and have that sandwich made for me. So with the declarative approach, I describe or I declare what the end result should look like. So I might say, I want a sandwich, a cheese and ham sandwich on brown bread with mayonnaise, lettuce and tomato. That is sounding like lunch right now. Now, I can, if I go into a sandwich shop, I can expect that the person making my sandwich has an understanding of my requirements and can then translate them into the sandwich that I want. I don't tell them exactly how to make the sandwich. I don't tell them, where the ingredients are, what they should be doing to get them, how they should be put together. The responsibility and the understanding for that lies with the the person making the sandwich at that point, which has some significant advantages, which I'll go into in a minute. When we look at an imperative approach, I might describe a series of steps, a series of commands, which, if they're followed correctly, would result in my sandwich being made to my desired specification. I would be giving instructions like, go and get me 2 slices of bread, brown bread, from the bread bin in the kitchen. And then I would say, go and get the mayonnaise, go and get the ham, cheese and tomato and all that. And they follow these instructions. And if these instructions are followed, exactly, hopefully anyone with a basic level of understanding of the instructions can go and make my sandwich to specification. But the responsibility and the information lies then within the instructions, within the imperative, not within the person who's making it. And so the responsibility, if something goes wrong, is with me as the person writing the instructions, and not with the person who then is just following the instructions. So if there is no bread in the bread bin, that person gets stuck at step 1 and they can't go any further. And so I either have to write a branch of code that says, if there's no bread, go out to the shop and buy some bread, and so on. And you have to incorporate in a lot of eventualities within your imperative instructions. When you flip that around, in the declarative side, I don't provide, the information of where you get your bread from, or where you get cheese and ham from, how you put it together. I just tell you what I want, and it's the responsibility and the knowledge sits with the fulfillment of that declarative. So aside from being hungry, hopefully that makes a little bit of sense to the differences between declarative and imperative. Now, another concept that we need to address when we're talking about this sort of thing is item potency. And this is the idea that if I was to say, issue my request several times, what would happen? What would the result be? If I say, I want my sandwich, I want my sandwich, I want a sandwich, do I get 3 sandwiches, as is the slide here, or as I like to term it, a small lunch? Or do I get the same sandwich modified? Do I just grind to a halt? Do I create a race condition? What happens, if I ask the same person for that sandwich more than once? What happens? Do I get a bunch of people queued up to make sandwiches for me, and all fighting for resources, all fighting over the last slice of ham, and resulting in an all-out battle royale for the last slice of ham, which one person eventually wins and everyone else dies and fails in a burning fireball of sandwich shop? I don't know. But this is the idea of idempotency, that we can incorporate the risk into a set of imperative instructions, which you can make imperative instructions idempotent in that they will check each stage before they then move forward. Or with declarative code, the responsibility rests with the mechanism for fulfilling the request. And when we're talking about this in the context of infrastructure as code, idempotency can depend on what's called the mutability of an object. So if we're deploying a virtual machine with an application on top, and we say, we make a change to our code and we execute the change, and our idempotent declarative code will make that change without having to chuck away the old thing. Then this is what we would term it as mutable. If we have to chuck everything out and make a new sandwich to get to where we want, this is what we'd call immutable. And different aspects of an environment can be both mutable and immutable. So again, if we're looking at a sandwich, swapping out 2 pieces of bread from brown bread to white bread we might be able to just scoop out the fillings and put it in the new slices of bread without affecting anything else. But if I've got mayonnaise on it and you don't like mayonnaise, we want to remove the mayonnaise, what happens is we need to be able to somehow remove that, and we can't, so we have to toss the whole sandwich and make a new one. And similarly, if we've deployed a VM with an application on top, maybe a database server, and we're running on Ubuntu Linux and we want to change that to CentOS, well, we can't rip out the underlying operating system. That's an immutable concept, and so we would have to redeploy the whole server in order to get to the point where our desired state is CentOS with MySQL running on top. And there's a direct relationship between application state and mutability, which when we're talking about application state, we might have to break out the state of an application into a persistent disk, but we can have our MySQL database running on a persistent disk, but we can then say, the operating system, we don't really care what you put as the value for the operating system. You can install it on any supported operating system because we have this immutable persistent disk, but everything else is mutable. We can change the RAM, we can change the processor, we can change the operating system. So long as the configuration points us back to our immutable disk, we can change anything else within the deployment. So I think am I over time now?
Technically, yes, but it's fine.
Okay.
We're into break.
It's fine.
Yeah. Okay. So I'm hungry. I need a sandwich.
What sandwich? Yeah.
I've yet to give my order in to my wife.
Stop making the pictures of sandwiches so big on the slides.
I know it was a bad idea, wasn't it? Or a good idea. Yeah. So this is the final. This is the end of my my meandering wander through these concepts and discussion of it. And I was hoping to get through it a little bit quicker so we could have more of a questions and discussion of it. But I'm also aware that I've made everyone hungry and am now eating into their break. So at which point, yeah, I'm going to stay on and during the break, and we can discuss stuff unless there's some burning questions that need answering now.
I just say I love the sandwich analogy.
I've been working on it for a while.
You did sound a bit crazy when you started on about your mayonnaise or no mayonnaise type thing, but other than that, it's all
people have strong feelings.
It, Sam.
People have strong feelings about mayonnaise and no mayonnaise.
They do.
Honestly.
They do.
Especially Americans.
Or
I
Benelux.
think it's a fantastic analogy and one I'm stealing.
Yep, likewise.
Well, good. At least I'm hoping that at least if nothing else, my ramblings will start people thinking about these kind of concepts. Yeah, and how you can apply them within a virtualization environment, within a VMware environment, or whatever environment it is you're managing.
This is such an alien concept, though, for a lot of vSphere admins, and so examples like this are brilliant.
Cool. Well, hopefully, yeah. If this fuels conversations and fuels the understanding of it, I've done what I came to do.
Yeah, I think it's really cool. So, I mean, do you see, I've got a question actually. I mean, do you see much discussion of DevOps in kind of financial services and kind of regulated industries? Because where they, particularly places where they have a requirement for a segregation of duties, for example.
Yeah. So it's an interesting one because I mean I've not done much with relation to financial services, but I have done a lot of discussions with telcos around this kind of area, and they're obviously very heavily regulated. If your phone system goes down and it's part of the national infrastructure, you get fined off the face of the planet. So a lot of I like the fact that there's a Mayo no Mayo conversation going on as well now. You get these risk averse environments, and ironically, the whole process is the idea is to reduce risk as much as possible. But I don't know. I find that these heavily regulated, heavily controlled environments like telcos and financials, they're gonna have their breakfast eaten by the new financial starts, so the fintech and the virtual telco providers. They're able to iterate and they're able to use these concepts to be more agile, and they start eating the customer base and they start eating the breakfast of the big incumbents. And so I don't think it's uncomfortable for these kind of heavily regulated and more risk environments, but at the end of the day, I think if they're not able to iterate and not able to move quicker, they're going to lose customers, and eventually they're going to be forced to change or die, aren't they?
Yeah, I mean, I always use the kind of example, particularly with the way things are done in the kind of DevOps model like that. Every change is actually submitted through code, right? So it's all it's all change controlled, right? It's all version controlled in source control. That process of kind of approving a PR is analogous to what you would do actually on-prem. It's just instead of signing off a bit of paper where someone says, I promise I'm going to do this, you're actually signing off the physical change itself, that the technical implementation of something.
Yeah. And as I said, the whole process is about reducing risk. Going back to that, the first kind of two sides of a coin between developers and operators. The primary concern of operators and the primary concern of these big industry where you have to have stability is keeping the environment up, keeping it stable, and you've got to be able to release features as well. So the whole thing is about managing risk and being able to evolve your product or your solution.
Sam, Al here.
Yeah.
I've got a quick question. Good session. Do you think it's possible to get some of the benefits of these approaches for a smaller outfit? Do you need to have a dedicated team, orchestration engines, automated deployment, CI/CD, or can you get some of the benefits of IAC, having your documentation and Git potentially? In your sort of experience, what are the lower limits where some of the benefits of this can be sort of felt?
Yeah, I mean, I think any environment, you've got to have a process for managing change, haven't you? And so while automation is kind of the nirvana of it all, having automated change around and that GitOps process, you can start at a very basic level. I have to make a change to a server. Well, how could I do that as code? You've got tools like Terraform open source, which is a really low bar of entry. That's the brilliant success of Terraform, is it's such a low bar of entry, to be able to automate infrastructure as code. You can do it from your laptop, and you can keep the configuration of your virtual machine or whatever, or your AWS instance. You can keep that as code within your GitHub repository, and you can start at that level, and you can go as you scale.
But it's basically self-evident that you need a Terraform or an Ansible, or this opportunity or this approach isn't open to anyone still driving a GUI, basically.
So the fundamental is being able to manage it as code. That's where the benefit is. The benefit is being able to version, being able to iterate, being able to have that traceable history. And while you could manually, write your configuration changes into your Git environment and then go and make the changes yourself or have someone else go and make the changes. But I guess you can take the principles, things like peer review. You could bring that in. So rather than just making a change yourself, you can validate it by peer review. But I think in order to see the benefits of this, automation, infrastructure as code, iteration are the keys. Yeah, it's a good question, because I haven't really thought about it in that sort of much smaller scale, and whether it does apply at that scale.
I suppose you are, and if you work for a larger organization where these things are in place, that's great. I'm thinking of, smaller teams, or even, as you say, some of the startups who are kind of getting their feet under the table, that it isn't simply, and it's not a challenge to you, but it's not simply then about Git or other things. You are sort of picking up a whole roster of tools that you're going to sort of need. And I understand that the barrier to entry for Terraform, for example, is low, but you are sort of committing your infrastructure team to a new language, a new tool set, new approaches, really. I mean, I guess it can depend on the type of business as well, but and also that if you're talking about a startup, you want to get good practices and good good methodology in right from the beginning, right? Because it will help when you scale. If you're presumably, the intention of a new startup is to be able to grow and to scale. And while you might not need all of the process when you're small scale, you've got to have one eye on the fact that you're aiming to grow, aiming to scale. But on the other hand, if you've got this, if you're running IT for a shop, and it's not your primary concern, is would this work? I don't know. I suppose that's kind of I'll jump off. I won't take up too much time. I suppose that's kind of my question: is if code is your product, if you are a fintech or a Revolut, and what your product is code, this is kind of embedded as a startup. If your startup is a mushroom farm and you're knocking up a few VMs, the utility or benefit of some of this is kind of is questionable, I suppose.
Yeah. I mean, I think anywhere that is configuration management and provides you with a safety net, it provides you with, to some extent, with like a DR path. It provides you, with audit and things like that. There are benefits that even a small place can have, but whether the ramp up to be able to get into that is outweighs the benefits, I don't know.
I think it becomes, particularly for small shops, right? If there are readily available templates people can take to get started, because I guess the worst thing is for all of the IAC type approaches, right? Building it up from scratch is difficult, right? And there is a big barrier of entry. It's almost, if there is, and there is, right? If you go and look on GitHub, there are, readily available kind of ready-built components. I want a server that does X. You can download an IAC definition and push it, and off it goes. Even in smaller shops, I mean, and I have to do this in a couple other places for just stuff of my own. It's a bit easier because then at least if it's broken, getting it back to a known good state is code, as opposed to having to sort of SSH into something and then monkey around with a whole bunch of config that you forgot about. So, even if it's, then to me, if there is that available marketplace, it's much easier to get started.
Yeah. And hopefully this, part of the idea of this session is to kind of lower the barrier a bit, to talk about some of these strange concepts that actually they're not that strange, they're not that alien to us if we translate them into sandwiches.
Everything always relates to sandwiches.
Is it lunchtime?
Nearly. Cool. Thanks, Sam. That was really good.
Thank you.